Good afternoon to all. As we discussed in the last lecture, correlations concept, and then we discuss in this topic is a mathematical method. One is a Carl Pearson's, and we completed that. And then after second correlations formula is the rank correlations formula. And in this formula, we discuss the mathematical methods where the formula for correlation is a R is equal to 1 minus sigma d square upon n into n square minus 1. So by using this formula we have to solve some example in the last lecture, and clear, that is the rank correlations definition. We discussed that, and then after its meaning, why we use that rank correlations, and then we learned this formula in the last lecture. The formula is 1 minus 6 sigma d square upon n into n square minus 1. So in this last lecture we discussed that if we need to measure the strength and directions of association between the two two rank data, we can apply this method, and that is the rule to evaluations of rank correlations answer. So that we already discussed, and that is the example we discussed in the last lecture, where the procedure is if the data is actual data, we need to first convert to the ranking form by using a highest value as a 1 or a lowest value as a 1, and then after using the d by taking it difference x minus y, and then take d square, and we need a total of the last column a sigma d square, and then after we have the formula is 1 minus 6 sigma d square of upon n into n square minus 1, and replace all the values where n indicate the number of data, total number of data. So in this way we can solve the rank correlation idea. So that's all example we have to learn in the last lecture, and in this last lecture we discuss about tied rank. Clear? And what is the meaning of that? Okay, if we have the two similar values, that two similar actual data, so we need to face a tied rank in these situations. So how we can solve such type of example that we discuss in the last lecture. So let us revise this topic again, and we have to solve some few more example in this topic. So what is meaning of tied rank? If there is a tied between two or more individual ranking, clear, it means in this example if we give ranking to this data, clear, there are two values are same, so we cannot give this is a third rank, it is a fourth rank here. Clear? So in this such case we have to face such type of tied situations. Clear? So how we solve such type of example? So if two item having the fourth rank and fifth rank, clear, then we have to consider this rank by taking its average. It is a 4 plus 5 divided by 2, so we have to give both to the 4.5 rank. Clear? If two item, clear, there is a two item are similar there at a fourth and fifth rank, then how we can map ranking to this value? So we have to take its average as a 4 plus 5 by 2, and that is a 4.5th rank to each of them. Clear? So that is the way you can implement the ranking to the each values, and then after we have to add one term in the to the sigma d square. So if m is the number of item having the equal rank, then factor 1 by 12 m cube minus m is added to the sigma d square. So done. So we have to use this factor to derive the answer of such type of data. Clear? So now there is more than values, clear, in tied rank form. Clear? So we have to use the formula as a, if there are more than one cases of this type, clear, then factor is added corresponding to each case. Clear? It means for first case you have to use the m1, for second case use the m2, for third case use the m3, m4 and so on. So the formula will be R is equal to 1 minus 6 sigma d square plus 1 by 12 m1 cube minus m1 plus 1 by 12 m2 cube minus m2 plus and so on. And denominator is n into n square minus 1, where n indicate the total number of data. So now let us consider this example again, clear, that we discussed in the last lecture. Obtain the rank correlations coefficients from the following data. Clear. So data is here 10, 12, 18, 18, 15, 40, and the data of y is 12, 18, 25, 25 and 25, 50. So here you can see that 18 is repeated 2 times and 25 is repeated 3 times here in the data of y. So now to solving that, we need to prepare the table first. Clear. So what the data we consider? First consider column of x that are given in the example 10, 12, then remaining values. Then take column of y 12, 18, 25, 25, 50, 25 and so on. So these are the data which provide in the example, and now we have to mention the rank to these values. Clear, because this is the actual data here, that is not called a rank. Clear. So we need to mention the rank to the values. Clear, by using the rules. You can use the highest value as a 1, or either you can use the lowest value as a 1. Okay, so in this column we are consider the lowest value as a 1 and highest value as a last rank. Clear. So in this column 10 is the lowest value, so consider 10 as a rank 1. Then after 12 is the second lowest value, so it is the rank is a 2. Then after 15, clear, so 15 is a rank 3, and then is a 18 and 18, so that is are in the 4th place and the 5th place. Okay, it is a 4th rank and 5th rank. So here we cannot mention here 4 and 5. So what we do for that, we take it as clear, it is a 4th rank and 5th rank. 4 plus 5, and how many times is here? 2 times. So 4 plus 5 divided by 2, so that is a 9 by 2, and 9 by 2 is a 4.5. so each you have to provide to the 4.5 rank. Okay, and the last one is a 40, so 40 is a 6th rank. Okay, so that is the ranking of the values of x, and now you have to mention the ranking of values of y. So the lowest value is a 12, so give to the rank is a 1. Then next is a 18, so this is a 2, and now next will come a 25, 25 and 25. That will be in place of 3rd, 4th and 5th. Clear, because we have to already mention the rank 1 and 2. So that value will comes to the 3rd rank, 4th rank and 5th rank. Clear, so here not mention the 3rd, 4th and 5th. Okay, so what we do in such case, we take its addition, that is a 3rd place, 4th place and 5th place. It is a 3rd rank, 4th rank and 5th rank. So take 3 plus 4 plus 5. 3 plus 4 plus 5, so that gives a 12. And how many times repeated here? It is repeated 3 times. 25 exists in this column 3 times here. So divide by 3. So 12 by 3 means a 4. So you have to give each of them a 4th rank. So it is a 4th here. It is also 4th rank, and that is also a 4th rank. So 1, 2, 3, 4, 5, and the last one is a 50. So you have to give 50 as a last rank, that is a 6th. Okay, this is the ranking when we have the same value in this actual data. So now take a difference, d is equal to the x minus y, so that we give 0, that is also 0. That is 4.5 minus 4 is a 0.5, that is also 0.5, that is a minus 3, and that will be 6 minus 4 is a 2. So here we get 0, 0, that is its square, so 0.5 square will be 0.25, that is also 0.25, minus 3 square will be 9, and 2 square will be 4. So take it total, 0 plus remaining 4 value, that is 0.25, 25, it is a 9 and plus 4. So 9 plus 4 is a 13 and that is a half. So it is called 13.5. That is called a sigma d square. And now in this formula we have two repetitions, that one is a 4.5 and second is a 4 in column of y. So 4.5 is repeated 2 times in this rank of x. Okay, so 4.5 is repeated 2 times in the rank of x. So for adjustment factor we have 1 by 2, 1 by 12, m cube minus m. So for that consider m1 is a 2. Okay, by using this ranking of x. Why it is m1 is 2? Because 4.5 are exist in 2 times in this column. So therefore m1 is a 2. And now for second ranking, a ranking of y, there is 4 is repeated 3 times. Rank 4 is repeated 3 times in this column. So for that use the second factor, second variable m2, and m2 use 3 times here, because 4 is repeated here 3 times in this rank of y. So m2 is equal to 3. So that is the explanation here. There are 2 times in the x series having the equal values, and that is the rank at 4, and each of is given the rank 4.5. So it is repeated 2 times in this rank of the x. So m1 is equal to 2, and similarly 4 is repeated 3 times in the rank of y, means series of y. So the m2 is equal to the 3. And now write a formula. So formula will be 1 minus 6 sigma d square plus 1 by 12 m1 cube minus m1 for the first factor, and second factor for m2. So it is 1 by 12 m2 cube minus m2. If there is m3 here, then use another factor plus 1 by 12 m3 cube minus m3. But there are only 2 repetitions here. One for is 4.5 in rank of x, and second is for a 4 in the rank of y. So divide n into n square minus 1, and now replace all the value. So 1 minus 6 sigma d square is 13.5. We have 1 by 12 m1 is a 2, so 2 cube will be 8 minus 2, 1 by 12 m2 is a 3, so 3 cube will be 27 minus 3, divide of 6 into 6 square minus 1. So now solve this bracket and take the divisions with this value, simplify that one. You can also do the practice, keep calculator with you, and check this answer also. Clear? That is a practice for you also. Take it. First solve this one. It is the 8 minus 2, 6 by 12, and that is the 27 minus 3, 24 by 12. That is a 2. That is a 0.5, and add 13.5, multiply with 6 and divide. That is the 35 into 6. So take it divisions and subtract from 1. So that gives answer is 0.5429. So that is a rank correlation between the tied data. Clear? That is the ranking are in tied form. Clear? The similar values there. Okay, so that example we discussed in the last lecture, in the last few minutes. Let us consider the second one. Calculate the rank correlations in the following data. And we have expenditure in the advertisement and the profit. Clear? How many you have to spend in the advertisement here, and that is the profit data. So it is a 10, 15, 14, 25, 14, 14, 20 and 22. That is the expenditure we have in advertisement, and that is the profit we have. Clear? That are the given data, and as you can see that is a 14 is repeated 3 times here. Okay, so that is a data is repetitions from that, and here 25 is repeated 2 times in this data. So that is the tied ranked. So let us denote the expenditure by X and profit by Y. So X we have 10, 15, 14 in this first column and remaining all values, and Y we have 6, 25, 12, 18 and this remaining all value. So these are the given in the data. X means expenditure and Y means a profit. So we need first a rank of X. Clear? So here we are using the highest value as a 1. Okay, so 25 is highest among this all data of this column. So 25 is a 1. Okay, so next is a 22. So 22 is a rank 2. Next is a 20. So 20 is a rank 3. And after that will come 15. So 15 is a rank 4. And now next will come the 5th rank is a 14. The 6th rank is also 14. And 7th rank is also 14. Okay, so what we do in such case, we will take additions and divide by how many times is repeated there. So it is the rank of 5th, 6th and 7th. So that will be 5 plus 6 plus 7. So 5 plus 6 plus 7 will be the 18. And how many times repetitions of 14 there? There are 3 times. So 18 by 3 will be a 6. So we will give a 6 rank to each of them. So write here 6. That is also 6 here. And that is also 6. Clear? Again repeat that. 14 will be in place of 5th rank. That is the 6th rank. And it is the 7th rank. Clear? Because 3 times repetition there. So what we do to assign the rank here, we will take it addition first. 5th, 5 plus 6 plus 7. So 5 plus 6 plus 7, that is the 18, and 18 by 3, that will give a 6. So assign a 6 to the each value. So it is a 6 here, a 14, that is also 14 here, to assign the 6. Okay, so now we have to assign 1, 2, 3, 4, 5, 6, 7, and the last is a 10. So that is the last value, and assign this as a 8 rank. Okay, so it is the 1 to 8 rank because we have data is also 8. And now for a Y. So there is maximum value is a 40 among this all data of this column. So assign 40 as a 1. Okay, then after next highest is a 25 and it is repeated 2 times. So you cannot write here 2 and 3. So what we do for that, that is in second place, second rank, and it is a 3rd rank. So that will give 2 plus 3, and how many times repeated there? 2 times. So 2 plus 3 is a 5 by 2. So 5 by 2 will give a 2.5. So assign 2.5 to these values. Assign 2.5 rank to these values. So here write 2.5 and here write a 2.5 rank to this value. Okay, so it is the 1, 2, 3, and now next highest is 18. So assign to the 4. Next is a 12. So assign to this is a 5. Then after is a 10. So assign to this is a 6. Then after 7, assign to this is a 7. And then after 6, so assign to this is a 8. Okay, so this is a rank of Y. That is, let us say R of Y. That is R of X. And now we take a difference. D is equal to R of X minus RY. Rx minus RY. So that will give us a 0. 8 minus 8. That is a 1.5. 6, 5 will be 1. 1 minus 4 will be minus 3. That will give 6. 1 is 5, that is minus 3, that is the minus 5. Okay, so this is a D, and now we need its square. So take its square in the last column. So D square will be a 0, square will be 0, that is the 2.25, that is the 1. This minus 3 will be 9, that is the 12.25. You can also check that. Clear? Keep calculator with you and do the practice also with me. Okay, so 5 square 25, that is a 9, it is a 25. So now take it total, addition of this all values, so that will gives 83.50. Sigma D square is equal to 83.50. So now for values of M. So in the rank of X, the 6 are repeated 3 times. Clear? This rank is repeated 3 times in this column. So we'll consider M1 is equal to a 3 for the rank of X, and there is no any number is repeated except that. And here in second column, a rank of Y 2.5 is repeated 2 times in this rank of Y. So for that we will consider M2 is equal to 2.5. Okay, so 6 repeated 3 times in rank of X, so M1 is equal to 3, and 2.5 is repeated 2 times in rank of Y, so M2 is equal to 3. And now total data, as we know that there are 8 values in the example, so R is equal to 1 minus 6 sigma D square plus 1 by 12. For M1 the factor will be 1 by 12 M1 cube minus M1, and for M2 the factor will be 1 by 12 M2 cube minus M2. Okay, if there is a third term M3, then add here third factor 1 by 12 M3 cube minus M3. Divide n into n square minus 1. So now replace all the values. The values we have 6 bracket 83.50, that is sigma D square that we derived. M1 is equal to 3, so replace 3 cube minus 3 here. M2 is equal to 2, replace 2 cube minus 2, and then after simplify this bracket, and denominator will be 8 of 8 square minus 1 n into n square minus 1 form. So replace n is equal to 8 there. So first solve that. 3 cube is a 27 minus 2, that will be a 2, that is a 0.5, so that will give 2.5. Add to the 83.5, take it total, multiply with 6, and that will give 516. Divide 504 and take it divisions, so we'll get negative rank association between the expenditure in advertisement and its corresponding profit. So this is a negative association between expenditure on advertisement and the profit. Okay, so that is the of rank correlations for the given data. In this data, there is expenditure is mentioned on advertisement and the profit. Okay, so that is the second example. Let's take third one. There is a more repetition that calculate the rank correlations coefficients from the following data. So data is here 70 70 80 80 80 90 100. So there is 70 repeated 2 times and 80 repeated 3 times, and here 90 repeated 3 times. Okay, so this is the data we have to solve the rank correlations coefficients from the given data. So let us first prepare the table. So data of x we have 70, 70, 80, 80, 80, 90 and 100. So let us assign the rank. Okay, so let us assign by the highest value as a 1. So we have 100 is the highest value in this column. So assign 100 to the 1. Then after 90, so assign 90 to the 2. Then after 80, so 80 will be in place of 3rd, 4th and 5th. It is in 3rd rank, 4th rank and 5th rank because it repeated 3 times. So we provide as a 3rd rank, 4th rank and 5th rank. So for that we will consider the additions of this rank 3 plus 4 plus 5. So 3 plus 4 plus 5 will give us a 12 and there is repetitions 3 times. So 12 by 3 will be a 4. So each of them we have to give to the 4. And then after it is a 1, 2, 3, 4, 5 and that is in place of 6 and 7th. Okay, so it is a 6th rank plus 7th rank. So that will be a 6 plus 7. It is a 13, 1, 3 and how many times repetition there? 2 times. So 13 by 2 will be a 6.5. So assign them 6.5 ranking to both values. Okay, so these are the rank of x. Let us say it is Rx. And now the values of y we have 90, again 90, it is 90, 80, 70, 60 and 50. So these 7 values we have. So let us assign highest value as a 1 and the highest value is a 90, 90 and this repetitions 3 times. This is the repetitions of 3 times here. So it is the 1st, 2nd and 3rd. It is a 1st rank, 2nd rank and 3rd rank. So it is a 1 plus 2 plus 3. So 1 plus 2 plus 3 will give a 6 and how many times repetition there? 3 times. So 6 by 3 will be a 2. So we will give 2nd rank to the each values which are in form of 90. So give this values is a 2, that is also 2, that is also 2. Okay, clear? 90 repetitions 3 times. It is in 1st, 2nd and 3rd. So 1 plus 2 plus 3, that is a 6 and that is repetitions 3 times. So 6 by 3 will be 2. So each will get a 2nd rank to the 90. So 2, 1, 2, 3 and now next is 80. So assigned to the 4. Then after 70 assigned to the 5. Then after 60 assigned to the 6. And then after 50 assigned to the 7. So these are the ranking of y. And now take it difference. So d will be this rx minus ry. So these are the difference. You can easily check that. Okay, so now we need it square. So take it square. 4.5 square will be 20.25. That is same. It is a 4, 0. Negative square will now convert to the positive. So it is a 1, 16, 36. And take it total. That is 40.5. That is plus 4 plus 1 plus 16 plus 36, 36. So we'll get 97.5. So this is the data of sigma d square. And now for the repetitions here in this rank of x, 6.5 is repetitions 2 times here and 4 is repetitions 3 times. Okay, so we'll now consider m1 is equal to 2 because 6.5 is repetitions 2 times. M1 is equal to 2 and M2 is equal to 3 for the column of rank of x, and here 2 is repeated 3 times also in the rank of y. So we'll consider M3 is equal to a 3. Clear? For the rank of Y. There is a 2 that which is in repetitions form. So 2 is repeated 3 times. So M3 is equal to the 3. M1 is equal to 2 for 6.5. M2 is equal to 3 for a rank 4. And M3 is equal to 2 for a rank 2 in the rank of Y. So M3 is equal to 3. So it's the data that we have to year 4 and 6.5 is repeated 3 times and 2 times respectively in the rank of X. So we'll consider M1 is equal to 3 and M2 is equal to 2. You can also interchange that M1, M2. You can take M1 is a 2, M2 is equal to 3. That doesn't matter in the answer. Clear? There is no any changes will reflect in the answer. And 2 is repeated 3 times in the rank of Y. So we'll consider M3 is equal to 3. Clear? So there are 3 terms, M1, M2, M3. Why? Because there are 3 repetitions in the ranking. One for 6.5, it is repeated 2 times. Then after 4, repeated 3 times. And then after 2 is repeated also 3 times. Okay, so this is the data we have. And now write formula for this data. R minus 6 sigma d square. And now you have to add the surplus term. First term for M1, so it will be 1 by 12 M1 cube minus M1. Second is for M2, so it is a 1 by 12 M2 cube minus M2. And third is for M3, so it is a 1 by 12 M3 cube minus M3. Divide n into n square minus 1. So that is the data. Now reflect the data in this formula. That is 97.5. That will give 3. M1 is a 3, so it is a 3 cube minus 3. M2 is a 2, so it is a 2 cube minus 2. And we have M3 is also 3, so it is a 3 cube minus 3. Okay, so number of data we have 7. The total number of data in this example, there are 7 values are mentioned in this example. So n is equal to 7. So now solve that. So solve this, all the 3 terms, take addition with 97.5, that will give 102. Then take that is a 49 minus 1 is 48 into 7, so that reflect 336. And after solving that, we will get a negative rank correlation, that is minus 0.82. Okay, when you solve that, we will get a negative rank correlations for the given data. That is our fourth one. Let us quick revise that because we are already know the procedure of that. Okay, and there is a data of marking in economics and mark in statistics, and we need to solve the rank correlations coefficients from the following data. Okay, so that is data is now mentioned in the example: 80, 80, 56, 50, 48. Then remaining all values. Then mark in statistic we have 90, 75, 75, 65, and remaining all value. So there are 7 students in this data, which in this we have the mark in economics and mark in statistics. So we need to check that the rank correlates between these 2 mark. Okay, that is in positive orientations or in negative orientation. Okay, so you can check that there is mark of student in economics 80 and there is mark is 790. Here mark is 50 in the economics and here mark in statistic is 75 for the third student. Okay, so that is the data we have, and we need to check first rank and then after replace the values in formula. So let us consider X is a mark in economics and Y is a mark in statistics. So the prepare column of X for the given data, then column of Y, and then now prepare the ranking data. So rank of X, let us say it is the RX, and we are consider the highest value as a 1 in this data. So 80 is the highest value, 80 highest mark in economics. So and Sanm, this is the first rank. Then after 62 is the second highest, so assign this is a rank 2. Then after 0 is the third highest, assign this is a rank 3. And then after 56 assign to the rank 4. And now 50 and this are repeated 2 times. Clear? 50 is repeated 2 times here, and it is in rank of 5th and 6th. Clear? Because we have to already assign 1 2 3 4 rank, so that value will comes in the place of 5th rank and 6th rank, and repeated 2 times. So 5 plus 6 divided by 2, so that will be the 11 by 2, and 11 by 2 is a 5.5. Okay, so now that is the rank of x, and last is the 48, so assign this is a 7. Clear? It is a 5 6 and 7. And now the values of y, we have 90, it is the highest among this all, so assign 90 as a 1. Then after next highest is 75, and 75 is repeated 2 times, and that is in place of second and third rank. Clear? Because 90 is the first rank, next is 75, and it is repeated 2 times, and it is will be in second and third rank. So that will be the 2 plus 3, and how many times repeated there? 2 times. So 2 plus 3 by 2, so that will be the 5 by 2, and 5 by 2 will be 2.5. so assign each of them a 2.5 rank. So that is a 2.5, that is a 2.5, so it is a 1 2 3. And now next is a 65, that is in place of 4th plus 5th plus 6th. Okay, because that is a 1 first rank, that is second rank, it is a third rank, so that will be assigned as a 4th rank, 5th rank and 6th rank. So take it addition, 4 plus 5, that will be 9, plus 6, that is the 15, and we get 15 by 3, because 65 repeated 3 times, so 15 by 3 will be 5. So assign each of them as a 5. Okay, so 65 repeated 3 times, so that we are consider a 5th rank, that is also 5th rank, and that is also 5th rank. So 1 2 3 4 5 6, and last value is a 50, so assign them as a 7. Okay, so that data we have. Take a difference, so this is the difference of that, and now take it square and derive sigma d square, so it is a 4.50. So now a 5.5. Okay, so for data of m, so 5.5 is repeated 2 times in this data, so consider m1 is equal to 2, and 2.5 is repeated 2 times in the rank of y, so consider m2 is equal to 2, and 5 is repeated 3 times in the data, so consider m3 is equal to a 3. So 5.5 is repeated 2 times in the rank of x, so consider m1 is equal to 2, and 2.5 and 5 are repeated 2 times, and 5 repeated 3 times in the rank of y, so m2 is equal to 2 and m3 is equal to 3. So write a formula for this case. For m1 we have to add this factor 1 by 12 m1 cube minus m1. For m2 we are adding the second factor 1 by 12 m2 cube minus m2, and for third, for m3, 1 by 12 m3 cube minus m3. Divide n into n square minus 1. So that is a formula to derive the rank of this data, and replace all value. Solve that example. That additions, take 44.5 multiply with 6, divide by 336, because it is 7 into 7 square minus 1, that will be 336. So at last we'll get 0.15, that is the rank correlations between the given data, and it is positive from that. Okay, so this is an example of the rank correlations coefficient of that, and these are the two example which is for your practice. Clear? So if you have a pen and paper clear with you, so write down this data here and try to solve yourself. Clear? That is the data we have, that is a tide rank form here, and here 32 is repeated 2 times, 25 is repeated also 2 times, and here 45 is repeated 2 times, 46 is repeated 2 times, 47 repeated 2 times. Clear? So there is lots of average term we have to consider that in this assign the ranking of x as well as ranking of y. Clear? So try to solve by yourself, try it, practice it. Clear? We have the simple formulas that r is equal to 1 minus 6 sigma d square bracket sigma d square plus 1 by 12 m1 cube minus m1, for second m2 cube minus m2, third m1 by 12 m3 cube minus m3, and division is n into n square minus 1, and subtract these values, these divisions from 1. Okay, so that is the simple formulas that prepare the first table and then derive the answer. That is the second one here. Clear? This second example you can also practice it. Clear? We will discuss it answer in our next lecture. Clear? But try it, practice it. Clear? We can solve or not. So this is the data we have. Okay, so it is a 2 repeated 2 times, 3 repeated 3 times, and here you can observe that is the rank is already defined. Clear? There is no actual data are mentioned in this example. Directly rank is mentioned there. So directly you have to revise the ranking form. Clear? And then you can take a difference of Rx with R. Clear? You have to modify this rank. Clear? Because 3 repeated 3 times, so for that we have to assign the ranking that is by taking its place and divide by the repetition. The repetition is 3 times that. Clear? And similarly that is the rank in Y. So you have to also modify this rank. Clear? By taking the repetitions form. So this are 2 example. Clear? Try it. We'll discuss in the next lecture. Clear? Okay, what is the answer of that one? Clear? So try it. Okay, so I hope you write down this data. Okay, so now what the topic we discuss in this rank correlation idea. Clear? So Spearman rank correlations concept. By using that, with the help of the rank correlations, you can find the association between the 2 characteristics. Clear? We have the 2 data at a time there, and by using this rank correlations we can find the association between that. Clear? Okay, what will be in positive associations, negative associations. Clear? As we know that the Karl Pearson's correlations coefficients give the intensity of linear relationship. Clear? That we have the formula of Karl Pearson's, which gives the intensity of linear relationship between the 2 variables. Clear? As we discussed in this first lecture. And the Spearman rank correlation means this formula. Clear? Which gives the concentrations of the association between the 2 characteristics. Clear? Which gives the concentrations of the association between the 2 characteristics, and it measures the association between the 2 ranked variables. Clear? So that is the use of this 2 formula of the correlations, and we can implement also to the real life to measure the intensity and the concentrations between the two variable. Okay, so that is the topic of correlation. And now second topic of this chapter is a regression. So what is the regression? So let us first consider this example here, and then after we will learn this definition and so on. That example here, clear? So that is the company data here of manufacturing companies there, and there is a product and they need to advertise it here, and then after it sell quantity here, clear? So it is a year wise data here. In the first year they have to spend the 90 lakh, clear, in advertisement, and there is a 440, clear, thousands of his product, clear, sells that. And then after in second year they have to spend 80 lakhs in advertisement of this product, and at that year the current sale of its product is a 390,000. And third year they have to spend 97 lakh to advertisement of its product, and at that year the sales of this product is a 470,000 in the third year. So now if we company spend 100 lakhs of its product, then what will be the predictions of the sale? Clear? What will be the predictions of the sale here? So that we can check, we can predict by using the regression data. Okay, and reverse scenario, if the company need a 600, clear, 600 sales of its product, 600,000 sales of its product, then how many company need to spend in advertisement to its product? Clear? So that we need to check, that we need to predict that how many company need to spend in advertisement to achieve a 600,000 sales of its product. So that need to check by using the regression. Okay, so that is the example. Again I recall that is one company, manufacturing company that, and that is the overview of its spending money in advertisement and of its sales, clear, of its product. So in the 1 year, clear, they have to spend 90 lakh in advertisement of its product, and this year the sales of this product is a 440,000, clear, 440,000 of its sale. And in second year the company spend 80 lakhs to the advertisement that, and this sales of its product is 390,000 at the year. And then after in third year company spend 97 lakhs to the advertisement of its product, then sales will be 470,000 in this third year. So now we check that, clear, we need to predict that, that is a predictions value. So if company spend 100 lakhs to the advertisement of its product, then what will be the predictions of the sale if company spend 100 lakh? So that we can predict by, we can check this value by using the regression, clear. And same reverse things, clear. If company need 600 sales of 600,000 sales of its product, then how many company need to spend to the advertisement of its product? So that we need to solve it here. So we can use a regressions concept to check that, clear. So that is the use of regressions in the business, clear, in the economics. So let us learn its definitions and its various properties and so on. So what is a regression? Regression is a concerned with the predications, the most likely value of one variable, then the value of other variable is known, clear. So you can also say in such a way that correlation depends on two variables, that both variable are random variable, clear. And regressions also defined for two variable, where one variable is a random variable and second variable is a fix. Clear? So regression is a concept with the predications of the most likely value of one variable when the values of other variable is known. Clear? So regression is defined as the method of estimating the values of one variable when that of other is known and the variable are correlated. Clear? So that is the definitions of regressions, as we check in the example that if company need a 600 cell in this year, so how many money they have to spend into the advertisement of its product. So they need to check here, so we can apply the regressions idea to check that. Clear? Where one value is a known, another you need to identify that. Clear? Which value is a known? Company need a 600,000 cells, so this is a known. Clear? That we are know that company needs 600,000 cell in this year. So how many they need to spend to advertisement of its product? So that is unknown, that they need to calculate by using the regression idea. Clear? So that is the definitions. Regression is defined as a method of estimating the values. So here we can estimate the values that can predict the values that of one variable when that of other is known. Clear? And variables are correlated. So that is the definitions of the regressions. It is highly valuable tool for predications purpose in economics and business. Clear? It is the very valuable tool for predications purpose in economics as well as in business. Clear? So it is a very important method in statistical form. It is useful in statistical estimations of demand curves, supply curves, production function, cost function, etc. Clear? So that is widely used in statistical estimations of demand curve, supply curve, production function, cost function, etc. Clear? So this is the example of that is useful of regressions here. Clear? That is a highly valuable tool for predications purpose in economics as well as in business. Clear? As we check in the example that manufacturing companies, clear, data for advertisement as well as its sales. So we need to predict the values by using the regression data. Clear? And there are types of regressions, as we'll discuss in the next lecture. There are two types. One is simple and multiple regressions, and second is a linear and non-linear regression. Clear? That we'll discuss briefly in the next lecture. So let us end these sessions. Clear? In next we'll revise the definition again. Clear? And its properties and its counter example we will solve in the next lecture. Clear? Okay, so let's end these sessions. Clear? Keep learning and stay at home.